In this sector, we're going to be talking about the application of solver in helping you to solve optimization problem. So first, maybe when you were doing optimization problem, when you saw the first order conditions, for instance, this was one example that we have gone through in slides 5-2. Okay, so here in order to solve for the first order conditions, here we actually have two equations, right? We derive the first order derivative of this function with respect to x and set that equal to 0, and we derive the first order derivative with respect to y and set that equal to 0. And here we have two functions. We have two equations. The first one is -7 minus 7x minus 3y plus 44 equals to 0. And when we move the variable terms to the other side, we have 7x plus 3y equals to 44. And for the second one, which is minus 3x minus 2y plus 21 equals to 0. And when we move the variable terms to the other side, we have 3x plus 2y equals to 21. And here we have actually two equations to solve for two unknowns. And it is actually similar when we were doing constraint optimization. The only difference is we have probably three unknowns to be solved from three equations. But here, actually, we have learned in Unit 1 on how to solve those kind of system equations with Excel. So this is how I plan to start this 5-4 section, which is to give you a little review. Okay, that is example 2 of 5-2. Okay, and here let's do A, which is solve systems of equations. Okay, so the system equations here, as we have solved out the detail, actually I have attached in the second slides, in the subsequent slides to follow. Okay, I will not go into the detail of how you derive this. You can refer to previous slides and previous recordings for the detail. So here we have 7x plus 3y equals to 44. And the second one is 3x plus 2y equals to 21. So we have these two. Then what we are going to do is we have x, we have y. And to me, it will be more convenient for me to do the constraint method, which is to say we set the goal of equalizing the left-hand side and right-hand side of the first equation with the constraint that the second equation holds. So here we're going to have, let me move them here. Here we're going to have equation 1. Equation 1 and equation 2. Okay, and we have left-hand side and right-hand side. So the right-hand side is straightforward, which are just constant numbers. The left-hand side is a combination of the calculation. I'll color this. And the left-hand side of the first equation is 7 times of x plus 3 times of y. Okay, the second one is 3 times of x plus 2 times of y. And then what you need to do is use data solver, set the objective, the first equation equals to the value of the right-hand side of the equation by changing x and y, adding the constraint that the left-hand side of the second equation just equal to the right-hand side of the second equation. and you hit solve, it solves the result, which is 5 and 3. That is the same as what we calculated by hand. So basically, you will still have to do the second order condition to make sure you're maximizing it, right? And you still have to do, when you're doing the second order condition, you have the first order derivatives already. You just need to set each of the first order derivative equal to 0 to form your first order conditions. Then what you can do is you can save the steps underneath. You don't have to solve them by hand, and you can avoid the mistake by letting solver to solve this system equation, which by nature are first order conditions for you. Okay, so this is the first part.